Hello students, we are solving the IB Math A HL past paper questions and currently we are solving the IB Math A HL May 2021 paper 2 time zone 1 past paper. And today we will be solving the question number 10 of this paper and you will be getting the links to all the previously solved question of this paper in the description area in the playlist. Okay, so we start with question number 10. It contains a maximum mark of 15 and it says consider the function f defined by f of x equal to 90 times e to the power of negative 0.5 times x for x belonging to the set of positive real numbers. The graph of f and the line y equals x intersect at point P. Let me show you the graph. This is the graph given and this is the graph of function f of x and this is the y equals x line. And they are intersecting at this point P. We are required to get the x coordinate of the point P, which is the subpart A of this question. Find the x coordinate of point P. And since this is a paper 2 question, we can use the calculator. So we will be using the calculator to find the x coordinate. Since they have asked us to give the x coordinate, we will be giving the x coordinate only, else we can give the y coordinate as well. Okay, so the function expression is 90 times e to the power of negative 0.5x. Okay, so let me go to the graph. It is 90 times e to the power of negative 0.5 times x. Enter. Okay. And let me draw the y equals x line as well because we need the x coordinate of the intersecting point. So this is equal to x. Fine. Now we need the x coordinate of the intersecting point. So analyze graph intersection. So it is 5.57 up to 3 significant figures. It will be 5.57. Okay. So we can write this as 5.57. Up to 3 significant figures. Okay. And we have got 2 marks. The line L has a gradient of negative 1 and is a tangent to the graph of f at the point Q. Line L, this is line L. It is tangent to the graph of f of x and tangent at this point Q. And this line L is having a gradient of negative 1. Okay, fine. Answer part B question is find the exact coordinates of Q. This time we are asked to give both the coordinates and they should be the exact coordinates of Q. Okay. We are knowing 2 things. One is the line L is meeting the curve of f of x at the point Q. So the y value, even the x value also, will be the same for that point. That xy pair should be satisfying the line equation and should be satisfying the curve equation because that point is common for both the f of x curve and the line curve. L curve. Not curve, but straight line. This is one of the information that we are knowing, we know. And the second information is that the line L has a gradient of -1. And how do we get the gradient of any point on the curve? By differentiating. So we will be differentiating f of x expression to get the f dash x, which will be the derivative. Okay. Why should we be doing? Because we have to get the exact coordinates of q. If we get the derivative expression and if we equate it to -1, because they are saying that the gradient of line L is equal to -1, then we can get the coordinate of the point of the meeting point of these two graphs. That is the x coordinate of the point Q. And if we know the x coordinate, we will be substituting that x value in the regional f of x function expression to get the y value. Plain and simple. Okay. So we will be doing the differentiation first of all. Okay. Okay. Let me write over here, or should I be taking this down? Okay. Let me take this down. So this is question or subpart B. I have brought it down and this is the function expression. So we will be getting the f dash x expression or the first derivative expression. Therefore, f dash x will be 90 is the coefficient. So we write 90 first and then the power will be coming down. Rather, the coefficient of the power will be coming down. So it is negative 0.5 and e to the power of negative 0.5 x. Okay. So, and I can simplify this a little because negative 0.5 can be written as negative half. So, this is negative half. I'm writing this as negative half so that I can cancel these two. And I get 45 over here. And it is e to the power of negative 0.5 x. So, this is basically equal to negative 45 e to the power of negative 0.5x, and this should be equal to -1 because the gradient of the line L is equal to -1. So I'm equating this to -1 to get the value of x. Okay, I can cancel these two negative signs first of all. And I don't want to do any more simplification because I'll be using the numerical solve or the calculator to get the x value. But there is a problem because they have asked for the exact coordinates. The computer will be giving, or sorry, the calculator will be giving me decimal values. So what do I do? No other option, maybe. So let us get the x value manually, okay, by just calculating or solving this equation, exponential equation. So what do? We can write if we divide both sides by 45, it becomes e to the power of negative 0.5 x is equal to 1 over 45. Okay. And then we take the natural logarithm of both the sides, that is ln. We are taking ln because we are having the e. So it is ln of e to the power of negative 0.5x, sorry, equal to ln of 1 over 45. Okay. And this is, the left hand side is negative 0.5x. And if I just separate these two terms, it will be ln of 1 minus ln of 45. And ln of 1, this is equal to 0. Okay. So basically we are having negative 0.5x is equal to negative ln of 45. Again, we can cancel these two. So this is actually 0.5 is x over 2. 0.5 is half times x. So half times x is x over 2 equal to ln of 45, or the x coordinate will be 2 times ln of 45. This is the x coordinate of the point P, rather point Q, sorry. And what will be the y coordinate? The graph, what was the graph expression? The function expression, rather, f of x. F of x was equal to 90 times e to the power of negative 0.5x. I'm showing you the expression once more. You see the expression was 90 times e to the power of negative 0.5x. So this is equal to, I'll be substituting the x value over here. It will be 90 times e to the power of negative, instead of 0.5, I can write this as half. And x is times 2 times ln of 45. And these two will be getting cancelled. So this is equal to 90 times e to the power of minus 1 can be taken to the power part of 45. So this will be e to the power of ln 45 raised to the power of negative 1. Okay. So this is equal to 90 times 45 raised to the power of negative 1, which is 90 times 45 raised to the power of negative 1 is 1 over 45. So y should be equal to 2. Therefore, the q will be having coordinates as, the x coordinate was 2 ln 45, 2 45 and 2. Okay, so this will be the x and y coordinates, the exact values of x and y coordinates of the point Q. So let me just write the coordinates over here. This is 2 times ln of 45, and the y coordinate is 2, and for the P we have not found the y coordinate of the point P, but the x coordinate is 5.57. So let me just write these two. I have written these two. I do not know whether I'll be needing them or not. And so far, these are the informations that we have collected. So let me write them. I have written them, and now I come to subpart C. Now this is subpart C. Show that the equation of L is y equals negative x plus 2 times ln of 45 plus 2. And in the previous subpart, we had seen that we had been given this information. The line L has a gradient of -1 and is a tangent to the graph of f at the point Q. And we had found the exact coordinates of the point Q as 2 ln of 45 times 2, not times, comma 2. Okay. So now, since line L has a gradient of -1, we can write the equation of line L y minus y1 equal to m times x minus x1. Okay. And m is -1, y1 is 2, x1 is 2 times ln of 45. So we'll be substituting these values. Y minus 2 equal to -1 times x minus 2 ln of 45. And this will be equal to y equal to 2 minus x plus 2 ln of 45, which can be written as y equals -x plus 2 ln of 45 plus 2. So this is the equation of the line L. You see, this is the equation that they have given, minus x, y equals minus x plus 2 times ln of 45 plus 2. So we have answered subpart C, and now we will be moving on to the subpart D. Now subpart D, it contains two further subparts, I and II. This was the graph given to us, and I have written the line equation and the curve equation. These are the two expressions. And the I says, find the x coordinate, only the x coordinate of the point where L intersects the line y equals x. Again, we will be taking the help of the calculator. We have already sketched or graphed actually the line f of x, curve f of x, and the line y equals x. Now we have to graph the line L. So minus x plus 2 times ln of 45 plus 2. Tab minus x plus 2 times ln of 45 plus 2. Enter. Okay, we do not actually need it, this one right now. So I can just shift it to this side. And now we are interested in getting this point, because this is the intersection point between these two lines, y equals x and the line L. This black colored line is the line L. So analyze graph, intersection, this one and this one. Okay, so we are seeing it is 4.0 8067, because it is, these points are lying on the line y equals x. Therefore, every point that we are taking, they are having the same x and y values. Has to be, because they are on the line y equals x. So the x value is 4.81 up to 3 significant figures. Okay. So we can write this as 4.81 up to 3 significant figures. Okay. That means this point, this is the intersection point between these two lines. So this will be having the x coordinate. Let me not write it as 5 point. Oh, sorry. It will not be getting erased. So I can just write it once more. 5.57, comma 5.57. And this one is also 4.81, comma 4.81. Okay, this is the point. I can name this point. I don't know whether I'll be needing this. The subpart II says, hence find the area of A. E is this. So let me just name this point. I'm not having any M over anywhere. So I can name this as M. Okay. The area A is the region MPQ. Therefore, we have to find the area of A, or the area of MPQ. So for that, we have to integrate, obviously. But what will be the limits of integration, and what will be the expression that we will be integrating? We know the process, but we have to know what will be the integrand and what will be the limits of integration. So for that, we find that this region actually can be divided into two parts. One is this, let me name this as, this point as N, this point as N, okay? And the x coordinate of this point M is 4.81, and the x coordinate of this A point or N point, it is 5.57. And the x coordinate of this point will be 2 times ln of 45. Okay. Now, we are having a small triangle PMN. Okay. What will be the area of that small triangle PMN? For that region, we are seeing it is bounded by the line y equals x, the line L, and the vertical line that has been dropped from the point P. The perpendicular dropped from the point P onto the x-axis. That defines that small triangle. Okay. So, when we think of what should be the expression, we are seeing that that region is bounded by two curves, two straight lines rather. The line y equals x is above the line L. This line is above this line. Okay. So the expression should be x minus this part Okay. Of course, we have to integrate with respect to x. But what will be the limits of integration? The starting x value is 4.81. The ending x value will be 5.57. So we have to integrate between these two limits, these two x values. So let us first of all write that. So it is I. The limits will be 4.81 to 5.57. And we are seeing that y equals x is above the line L. So it will be x minus line L's expression minus x plus 2 times ln of 45 plus 2. Minus x plus 2 times ln of 45 plus 2. Okay. Dx. And plus, now the second part is what? Okay, let us do the two integrations separately. Let us first of all get this. We know that we have to get the area of this part as well. So first of all, let us get the area of that small triangle. Okay? So this will be equal to the limits will be 4.81 and 5.57. X plus x will be 2x. And this will be minus, I can write this minus 2 ln of 45 plus 2. 2x because minus of minus is plus, so x plus x is 2x, and these are all, this is a constant expression, so I'm keeping minus of 2 times ln of 45 plus 2 dx. Now I can just separate them and I'll be getting two integrations, two integrals. The first one will be this one, x dx. And the second one, this is a constant expression, so I can take the whole thing outside. Okay. And the first one after integration will be giving us x squared over 2. So it will be 2. So 2 can be taken out actually. And it will be x squared. So x squared minus 2 times ln of 45 plus 2 times x. Okay. And 2 over 2 is 1. So we have this as 5.57 whole square minus 4.81 whole square minus 2 ln of 45 plus 2, and this is 5.57 minus 4.81. Okay. Now obviously I have to use the calculator. Let us find the values of each of them separately, or why should I be doing them separately? I can write the entire expression. 5.57, let me go to the calculator. 5.57 whole square minus 4.81 whole square and then what is it? 5.57 whole square minus 4.81 whole square minus 2 times ln of 45 plus 2 minus 2 times ln of 45 plus 2 times 5.57 minus 4.81. Okay, I think I have taken everything. 5.57 whole square minus 4.81 whole square minus 2 times ln of 45 plus 2 and this. Right. So let me press enter. Okay. 0.5826. I'll not be taking up to 3 significant figures because I have to add another region's area as well. Okay. For this answer, I'm not taking up to 3 significant figures. I'll be taking more number of digits. Okay. So 0.582673, I'm taking all of them. 0.582673. So this is 0.582673. Okay. So this is the area. Area 1, let me see. Okay. And this is area 1. This is area 1 and this is area 2. Okay. Now we have to get the area of this area 2. For this area 2, we are seeing we don't have the y equals x line anymore. It is between the f of x curve and the line L, because this is the line L. Okay. So, and the f of x curve is above the line L. Previously, y equal to x line was above the line L. Now, f of x curve is above the line L. Okay. So, we will, and what will be the limits? From 5.57 to 2 times ln of 45. Okay. So, for area 2, it is the integration limits will be 5.57 and 2 times ln of 45. What will be the expression? It will be f of x minus line L. F of x expression was 90 times e to the power of negative 0.5x and minus x plus 2 times ln of 45. I'll be showing you the expressions once more. Dx. Okay, I'm showing you the expressions. F of x is 90 times e to the power of negative 0.5x and L is y equals negative x plus 2 times ln of 45 plus 2, and the limits will be 5.57 to 2 times ln of 45. Okay, and f of x is above the line L. So we'll be writing the f of x expression. We have written the f of x expression before the line L expression. Okay, so let us just use the calculator. The previous one was comparatively easier than this one, this integration. It's not doable without calculator. We can do it, but let us use the calculator because we are having the calculator. So we will be, let us take the calculator. Menu, calculus, numerical integral. It is 5.57 is the lower limit, and the upper limit is 2 times ln of 45. And this one is 90 times, oh, let me put bracket, 90 times e to the power of negative 0.5 times x minus x plus 2 times ln of 45 plus 2. Okay, and it is dx. Okay, let us press the enter key. It is 0.936998. So this is equal to 0.936998. This is the area of area 2. Okay, that was area 1. Where is it? Oh, over here. That was area 1 and this is area 2. Okay, now we have to just add them. Okay, so this one I'm taking as the answer and I'll be just typing the previous number, 0.582673. Okay, enter. It is 1.52. Up to 3 significant figures, it will be 1.52. Okay. Therefore, area of region A is equal to area of subregion 1 plus area of subregion 2 equal to 1.52 unit square up to 3 significant figures. Okay. So this is the answer for the II subpart of the subpart D. But this doesn't complete this question number 10. It has one more subpart, so let us bring that. Now, this is the last subpart of question number 10, and it says the line L, this is the line L, is tangent to the graphs of both F, this is the F graph, and the inverse function F inverse. This is the graph of F inverse. Okay. And the question is, find the shaded area enclosed by the graphs of F and F inverse and the line L. This one. And it contains just 2 marks. And this, let me tell you, this is not only a question for the HL students, this is also a question for the SL students. And they are also having all the 5 subparts. Okay. So, if it is a challenging question for you, particularly this subpart, the last subpart, it is challenging, even more challenging for the SL students, I think, should be. And it is containing only 2 marks. So what you can do is, since you are HL students, I think you should be understanding, you should be seeing the symmetry. You should be able to see the symmetry. Let me show you where is the symmetry line. So there, maybe this is the line. This is the, okay, let it be. So this is the y equals x line. Okay. And this was the point P. This was the point Q. This was having the coordinates as 5.57, comma 5.57. Okay, and this was named by me actually M. And this was having the coordinates as 4.81, comma 4.81. And we had found the area of this part in subpart DII. We have found the area of this part. And it was equal to 1.52. Let me show you. Area of region A. This was named as region A, and the area of it was found to be equal to 1.52 up to 3 significant figures. So by symmetry, because one is f of x curve and another is f inverse of x curve, therefore, and the line L is the same, therefore you should be knowing that this Q was having coordinates as ln of 2 times ln of 45 times 2. And this, so because Q is this, let me name this point R. R will be having coordinates as 2, 2 times ln of 45, because R and Q, they are, one will be the image and another will be the object, and they are just getting reflected on the line y equals x. So the x and y coordinates will be just getting interchanged for the points Q and R. Okay. And the PM points remain the same for the for this part, for the yellow region and for the gray region. The PM part, PM line is the same, and Q and R, they are just having their x and y coordinates interchanged. The line L is the same. So by symmetry, you can see if the yellow colored region is having an area of 1.52, the gray color region will be also having an area of 1.52 units square. And if we add them, it will be 1.52 times 2. It is 3.04. Okay. So, and this you should be able to visualize because it is containing only 2 marks. Otherwise, what you have to do is you know the coordinates of the point R, and then you have to again find the area of the region, of that region, gray colored region. So that will be taking much more time. If you have that time, fine. In case you are not being able to visualize this, I would say that this is question number 10. You will be having question 11 and question 12. Those 2 questions are remaining. So you don't spend, if you cannot visualize this symmetry, just don't waste time for these 2 marks. Move on to questions 11 and 12. Complete them, recheck your answer. Then if you have the time, some more time remaining with you, then you can come to this part. Because if you cannot visualize the symmetry, you have to again go for separate integrations to get the area of that part. You will be able to, definitely. But again, that will be taking some time. Okay? Because if you let me just show you, in case you want to get the area of this gray colored region, again you have to get it like this. So this will be, the x coordinate will be 4.81. The y coordinate of this point will obviously be equal to 0 because it is on the x-axis. And this side is between the curve f inverse of x and the line L. And this small triangle is between the curve f inverse of x and y equals x. So again, you have to go for 2 integration, and of course the x value for this will be 5.57. And you need this x value as well. You are having this. So between 2 and 4.81, you have to integrate, and the expression will be the expression for f inverse. For that, first of all, you have to get the expression for f inverse, because you know the expression for f of x. You have to get its inverse expression first of all, and then you know the expression for line L. Then you have to do the integration. Integration limits will be from 2 to 4.81. And next integration will be between the f inverse x expression and the y equals x line. And the limits will be 4.81 to 5.57. This will be a time consuming one, definitely. So if you cannot see the symmetry, I would definitely suggest leave this part. Complete question 11 and question 12, recheck your answers, and then even after doing everything that has to be done, you still have some more time with you, then you come to this part. Okay, it is containing only 2 marks. So I am not doing this integration. Let me just write the answer for this. Let me just name this as area A because it was named as area A, and this as area B. Okay. And I can write that from subpart D, DII, we know the area of the region A equal to 1.52 unit square. Okay. Area A is bounded by the line y equals x, the line L, and the curve f of x. Okay. This is the region B. I have to scroll, that is why I have shown you before. Okay, scrolling. So area B is bounded by the line y equals x, the line L, and the curve f inverse of x. Therefore, by symmetry, by looking at the symmetry, of the two regions, we can say that area B is equal to 1.52 units square. Okay. Therefore, area of the shaded region equal to area A plus area B equal to 1.52 plus 1.52, that is 3.04 units square. Okay. So this is the answer for subpart E. And again, I am telling you, if you cannot visualize this symmetry, just leave this question, this subpart, and move on to question number 11. Okay. So students, we have completed the question 10, and thank you for staying with me till the end. We will be solving question number 11 in our next session. And I'm Nilanjana Sanyal, and I tutor IB Math A, SL and HL students from India and from outside India. And I'll be starting my online math tutoring sessions from the month of July. So as you can see over there, here, most probably you are being able to see. If any of you is interested in joining my classes, or you know any student who is interested, please contact me. You can contact me, you can mail me, you can text me. You are having my email ID, you are seeing my WhatsApp number, so you can contact me. Okay? And till our next session, bye.